Last time we figured out how to interchange the different types of information that we can have about a line and then use this sort of little flowchart to help us to find our way through the solution of problems involving working with equations for lines. And the big central concept in all this, it's central because it's in the middle, but it's also most important, is slope. If you can wrap your heads around what slope is, what it means, how to compute it, how to use it, that's really one of the more important things you can take out of this course in general that will help you in pre-calculus next semester. It'll continue to help you in calculus the following semester. So I think the single most important idea that goes into our course that's going to follow you through your next 2 and even 3, however many semesters in your calculus sequence you have ahead of you. So we looked at a few things. We looked at how to, from an equation for a line, so from something of the form y equals mx plus b, we figured out how to determine the slope of that line by just reading off the coefficient of x. The m in this equation is the slope. So whatever is the coefficient of x, that is what we call the slope of that line. But that doesn't really do much to tell us what slope really is. Rather, to get a sense of what slope really is, we go back to how to determine the slope of a line knowing 2 points on that line. So if you give me 2 points, as this particular problem does, we can find the slope of the line that joins those 2 points by, according to this formula over here in the corner, this is the magic key to understanding what slope is, by dividing the difference in the y-coordinates by the difference in the x-coordinates. So what we're measuring is an amount of vertical change on the graph, an amount of horizontal change on the graph of that line, and what is the ratio between those two. So we're subtracting first and then dividing, and that gives us a relative measurement of how much points along this line change vertically compared to how they change horizontally. So having a larger slope leads to a steeper line. Having a smaller slope leads to a shallow line. Having a zero slope gives us a horizontal line, and so forth. So the slope is a measurement of a direction or a steepness. Which direction is this line going in? So if I have 2 points along that line, or if I can find 2 points along a line, I can compute the slope by dividing the differences in y by the differences in x. And with that information, with the slope, we can then try to determine an equation for a line of the form y equals mx plus b, except the problem is the slope doesn't tell us b, it only tells us m. Right? Slope is that coefficient of x, but the b, the constant in that equation, tells us where that line intersects the y-axis. It tells us the y-intercept of that line. And so before we can determine a complete equation for a line, we also need to know what that y-intercept is if we're going to use the y equals mx plus b form. And we can find that intercept using any of the points that we know are on the line, in addition to the slope that we now know the line has. And with those two pieces of information together, we can plug an m, an x, and a y into this equation, and then use algebra to solve for b. And that was the shape of the problems that we did last Wednesday. That was the shape that those problems took. So what I'd like to do next is to import this whole circle of ideas to work on a new problem in which we're going to use slope in a slightly different way. So I'm going to bring the same diagram back over to what we're doing. And let's think about what this problem is asking us to do. So I'm going to try and get us set up and let you in your rows try and work on this problem. So here they're asking us to consider the line, and then they're giving us an equation, 7x plus 2y equals negative 3. And immediately we see that there's a difference, there's a problem, there's something new. Namely, they give us an equation for a line, but it doesn't look like y equals mx plus b. The y isn't by itself on one side, and the x is all on the other side. Instead, the y's and the x's are mixed together on one side of the equation. So what this is it's a different form. It doesn't mean we can't do it. It just means that we might have some additional steps along the way of figuring out how to use this information that we have. So what this equation tends to get called is a general form. So, or standard, probably, using standard form. Display's been really blinky today. I don't know what's going on. And so the standard form of an equation for a line has the x's and the y's on the same side, as a constant on the other side, and then the x's and the y's have their own individual coefficients. So ax plus by is equal to c. This is what's called the standard form of an equation for a line. And in this example, we're asked to determine what is the slope of a line which is perpendicular to the line that we're given, and also what is the slope of a line that's parallel to the line that we're given. So ultimately, where we want to end up in this example is we need to end up in the middle, right? We need to end up figuring out what slope the line that we're trying to figure out might have. Problem is, we don't know how to get there from the standard form box. We know how to get there from the equation for a line y equals mx plus b box, right? Because there we can just read off the m, right? Read off the coefficient of x and be done. So, one way of going about this problem is to take us from the standard form to the slope-intercept form that we know. So I'm going to ask you, if we have a line whose equation is 7x plus 2y equals negative 3, how can we determine the mx plus b form from that equation? What do you think we have to do? What's our task?
Get the y by itself.
Get the y by itself, exactly. That's all we need. That's what characterizes, that's what separates slope-intercept form from standard form, is the fact that in slope-intercept form, the y is by itself. So all we need to do is just solve for y. Get y by itself. Get y alone. If I do that, then I should be able to just read the slope right off of it. If we want to determine what the slope of this line that we're given is, because our original equation is in standard form, we wanted to solve that equation for y so that we can identify it in mx plus b form. So what were your steps? From 7x plus 2y equals negative 3, what did you do first?
Divided by 2 by 3. 3 by 2.
So divide everything by 2.
Yeah.
Divide by 2. Divide by 2. Okay, so now I've divided by 2 on both sides. What else? What next? Not that that first step is wrong, but did somebody do a different first step here? What'd you do, Nafeni? Okay, so the other option from step 1 here is instead of dividing by 2, we'll follow the reverse order of operations, which tells us if we're trying to solve for a variable, do all of your addition and subtraction first, then worry about multiplication and division, then worry about exponents, and work from the parentheses, if there are any, from the outside in. All right, so it's reversing the order of operations. And according to that philosophy, the first thing we would do, if we're trying to get the y by itself, is subtract 7x from both sides. And again, dividing first is not incorrect, but it often leads people to do things that don't make sense down the line. Because if I'm going to do division before I do addition and subtraction, I'll have grouping issues very often. So if I do the subtraction first, now my left-hand side is 2y, and now if I divide by 2, I'm going to have just the y alone on the left-hand side. And I probably got the same thing that you got dividing by 2 the first time, but now when I'm dividing by 2, I'm going to be real careful that I am dividing everything by 2 on both sides. So that the equation I get is y equals negative 3 halves minus 7x over 2. And according to that equation, what is the slope of this line? Yeah, so the slope of my line is going to be found right here, right, in the term that has the x in it. But also remember, the slope is always a number. So I agree with everything you said except for the x. We don't want the x as part of our slope. Instead, the slope is just the coefficient of the x, negative 7 over 2. So when all of that dust settles, what we find out is that the slope of the line that we've been given in this problem is negative 7 over 2. And so that slope is for the original line that we started with in the problem. So we've now measured the slope of the line that we started with. So far, so good? Now let's go to the rest of the meat of this problem. Now that we know what the slope of our original line was, I'll try and mark this here. This was the original line. We also have the issue that in parts A and B, what we're supposed to do is come up with equations for new lines that satisfy certain criteria. So we're going to need this whole apparatus again. potentially, because each of these questions is going to ask us to find an equation, or actually, I guess in this example, find just the slope. And in a later question, we might also need to find an equation. Let's talk about each of these pieces individually and talk about how to find the slope of a line given this kind of information. Given a line that we know something about, so now we have a line that we know its slope is -7/2. Now we'd like to be able to import information about that line that we know that relates to how to find the slope of a perpendicular or how to find the slope of a parallel line. So those are going to be the two flavors of relationship between lines that we can answer using a slope. So let me start at the end for part B. Let me ask about parallel. If I have two lines that are parallel, what does that picture look like? What does it mean for one line to be parallel to another line?
They don't intersect.
They don't intersect. That's the rigorous geometrical definition that I tell my math majors of what it means for two lines to be parallel. It means they have no intersection point. So then our question for us in analytic geometry, which is what we do when we draw lines on a coordinate system, in analytic geometry the question is, what do two lines that never intersect share in common on this picture? How can I tell based on the slope of two lines whether or not those lines never intersect?
Same slope.
Right. The two slopes should be exactly the same. So parallel means exactly the same slope. So what that means is let's try answering part B of this question right now. Part B asks, what is the slope of a line which is parallel to the one that we were given? What would you say? What would the answer be? -7/2. Exactly the same as the slope of the original line that we were given. Just take that same slope and just keep it, just run with it. Okay? And that's how we get a line which is parallel to an original line that we were given. So don't touch the slope if what you need is parallel. Just use it. Use the one that you find. Use the one that you're given. So that's for parallel. How about perpendicular? First of all, perpendicular is a big word. What does it actually mean? What does the word perpendicular actually mean? So you're thinking ahead. You're thinking analytic geometry. Yeah, it's an inverse. In a sense, it's like the opposite of parallel. What do two lines that are the opposite of parallel look like? How do they intersect one another? Okay, they intersect each other at a point in the middle, and what kind of an angle do the two lines make at that point if they're perpendicular? 90-degree angle. So perpendicular means that these two lines meet at a right angle. So if one of my lines looks like this, then the other line had better look like that. Right? Perpendicular means that they make a 90-degree angle with one another. Okay, so two lines which are perpendicular, we expect their slopes not to be the same, but we expect them to be inverse to one another somehow. Right? And if we're thinking about slope, what are some ways that I can inverse the number -7/2? So one of the ways I can inverse it is by flipping the fraction upside down, right? Turning it into its reciprocal. And that is a part of our solution. So reciprocal, that's got to be a part of the conversation. So if I take the reciprocal of -7/2, that's going to turn it into -2/7. Now here's my question. Based on what we talked about last time, give me a reason why not to believe that -2/7 is actually the correct slope here. Why should I be suspicious of that as the slope of a line which is perpendicular to that one? So if let's say that my original line, my -7/2 slope is this yellow one. And let's say that I come up to you on the street and I tell you that this other line has a slope of -2/7. Why should you not believe me?
It's both negative.
What's wrong with that?
That's not exact opposite.
Why not? So which of these two lines that I sketched down here do we not believe has a negative slope? The yellow one or the gray one? Which of those two slopes has to be positive based on how it's drawn? The gray one. Why? What kinds of lines have positive slopes? What does positive slope tell us? This is an important insight for calculus, for sure. If a line has a positive slope, what is it doing on a graph? It's rising. As we go from left to right, we should see that line going upwards. Right? And if one of my two lines in this perpendicular pair is going downwards, and the other one meets it at a right angle, that other one's got to go upwards. Try drawing the picture a number of different ways. You'll find out that perpendicular lines always have to have opposing slopes in a positive-negative sense, as well as in the reciprocal sense. If one of them is increasing, the other one has to be decreasing. And so in addition to inverse in the reciprocal sense, we also need inverse in the additive sense. In other words, we need to flip the sign. Not only reciprocal, but opposite. It's two types of flips combined into one. So not negative 2/7, but instead positive 2/7. And then we'll have it. That wasn't a rigorous geometric proof of why this should be the case, but it's a heuristic argument. So we flip the fraction over so that we interchange the x and the y directions, and we make it from positive to negative or vice versa to fix the fact that one of them needs to be increasing while the other one needs to be decreasing. So finding the slope of a perpendicular line, we flip to the opposite reciprocal. Flip the fraction upside down and change its sign, which is the most work that we have to do in one of these problems for a slope, because if we want parallel, we leave it exactly the same.